Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P3, Variant 2, February-March 2019. Let's get started. 60 boys are asked to name their favorite sports. The results are shown in the pie charts. Write down the most popular sports. The most popular sport is the sport that has the highest sector angle. From the pie chart, we see that swimming has the highest sector angle. Write down the fraction of boys who choose running. This is equal to the sector angle for the boys who choose running, which is 72 degrees divided by 360 degrees. This simplifies to 1/5. Work out how many boys choose judo. To get this number, we divide the sector angle for judo, which is 30 degrees, by 360 degrees and multiply by 60. This gives us 5. One of the boys is chosen at random. Work out the probability that his favorite sport is not judo. The probability that the favorite sport of the chosen boy is judo is equal to the number of boys who chose judo, which we found to be 5, divided by the total number of boys, which is 60. To get the probability that the favorite sport of the chosen boy is not judo, we subtract this probability from 1. This gives us 11/12. Complete this statement. 3 times as many boys choose blank than choose blank. On the pie chart, the sector angle for judo is 30 degrees, and we see that the sector angle for tennis, which is 90 degrees, is 3 times as much as that for judo. So 3 times as many boys choose tennis than choose judo. 2 of the boys in Part A then change their choice from running to swimming. Complete the pie charts after this change. The tennis, judo and hockey sectors have been drawn for you. To get the sector angle for the 2 boys, we divide 2 by the total number of boys, which is 60, and multiply by 360 degrees. This gives us 12 degrees. So to get the new sector angle for running, we subtract 12 degrees from its initial sector angle, which was 72 degrees. This gives us 60 degrees. To get the new sector angle for swimming, we add 12 degrees to its initial sector angle, which was 120 degrees. This gives us 132 degrees. Using a protractor and a ruler, we measure and mark these new sector angles on the pie chart. 60 girls are asked to name their favorite sports. Their results are shown in the bar charts below. Using your pie charts in Part B and the bar chart above, write down one similarity and one difference between the girls' results and the boys' results. When we compare the girls' bar charts to the boys' pie charts, we see that they have one similarity, which is that swimming is the most liked sport for the boys and for the girls. And the difference is that judo is the least liked sport for the boys and hockey is the least liked sport for the girls. Write down the fraction of the rectangle that is shaded. Give your answer in its simplest form. To get this number, we divide the number of shaded boxes in the rectangle, which is 8, by the total number of boxes, which is 30. This simplifies to 4/15. Write down a fraction that is equivalent to 7/12. To get a fraction equivalent to this, all we need to do is multiply the numerator and denominator by the same number. We can't use 1 because then we get the same number. If we pick 2, we multiply the numerator by 2 and the denominator by 2, so we get 14/24. Write down a fraction that completes this calculation. 13/11 times blank equals 1. The number that multiplies 13 over 11 to give 1 is the reciprocal of 13 over 11, which is 11 over 13. Find a fraction that makes this statement true. 7 over 9 is 0.777 and 8 over 9 is 0.888. So using trial and error, you can come up with a fraction that sits between this range. A trick I used to arrive at this fraction is that I realized the two fractions have the same denominator, which is 9. So if I want a smaller fraction, I need a numerator between 7 and 8. So I picked 7.5. When we type 7.5 over 9 into the calculator, we get the simplified fraction to be 5 over 6. Write these numbers in order, starting with the smallest. To be able to compare the numbers, let's convert them to a percentage by multiplying each number by 100%. The smallest percentage is 57%, which is 5.7 times 10 raised to the power negative 1, followed by 57.14%, which is 4 over 7, followed by 57.2%. Followed by 57.45%, which is square root of 0.33. Maya shares $3,000 between her three children. She gives the eldest child $1,200, the second eldest child $1,000, and the rest to the youngest child. Write this information as a ratio in its simplest form. We are told the eldest son receives $1,200. The second eldest receives $1,000. To get the amount the youngest receives, we simply subtract the sum of $1,200 and $1,000 from $3,000. This gives us $800. When we divide through by 100, we have 12 is to 10 is to 8. And when we divide through by 2, we have 6 is to 5 is to 4. Yanni's house is for sale. She decides to reduce the selling price of $240,000 by 15%. Calculate the new selling price. Since she reduces the selling price by 15%, we subtract 15% from 100%, which gives us 85%. So the new selling price is 85% of $240,000, which is equal to $204,000. Hawa invests $750 at a rate of 3.5% per year compound interest. Calculate the value of his investment at the end of 3 years. In this case, we need to apply the compound interest formula. Big A represents the final value of his investment, which is what we are finding. Small a represents his principal, which is $750. R is the annual rate, which is 3.5%, and T is the time duration in years for the investment, which is 3. When we type this into the calculator, we get $831.54 rounded to 2 decimal places. A car park has 880 parking spaces. Some of the spaces are reserved. The ratio of reserved spaces is to not reserved spaces equals 1:10. Work out the number of spaces that are not reserved. To get this number, we divide the ratio share for the not reserved spaces, which is 10, by the total ratio, which is 1 plus 10, and multiply by the total number of parking spaces, which is 880. This gives us 800. 25% of the 880 spaces are on the top floor. Work out the number of spaces that are on the top floor. To get this number, we simply multiply 25% by 880. This gives us 220. At 6 o'clock one morning, 1 over 40 of the 880 spaces are filled. By 6:30, no cars have left the car park, but another 1/5 of the 880 spaces are filled. Work out the fraction of the 880 spaces that are empty at 6:30. To get the number of empty spaces, we subtract 1 over 40 of 880 and we also subtract 1 over 5 of 880 from 880. This gives us 682. So to get the fraction that is empty, we divide the number of empty spaces, which is 682, by 880. This gives us 31 over 40. The cost of each visit to the car park is shown in the table. Samath arrives at 11:40 and leaves at 15:30. Find the cost of his visit. First, let's find the time duration of his visit by subtracting his arrival time, which is 11:40, from his departure time, which is 15:30. Under the minute column, we can't subtract 40 from 30, so we get 1 hour from the hour column, which becomes 60 minutes under the minute column. So we have 90 minutes. 90 minus 40 is 50. Under the hour column, 14 minus 11 is 3. So we know the length of his visit was 3 hours 50 minutes, which falls within this range. So the cost is $4.50. Radhika leaves the car park at 17:50 and pays $8.50. Work out the earliest time she could have arrived at the car park. If Radhika paid $8.50, then it means the earliest time she could have arrived was 8 hours ago. So to get this time, we subtract 8 hours from her departure time, which is 17:50. Under the minute column, 50 minus 0 is 50, and under the hour column, 17 minus 8 is 9, so we have 950. Work out the change she receives from a $20 note. To get the change she receives, we simply subtract the cost of her visit, which is $8.50 from $20. This gives us $11.50. Drav bought a weekly car park ticket for $26. That week, he visited the car park 4 times. These are the lengths of time he parked his car for. Work out how much he saved by buying a weekly ticket. If he parked for 17 minutes, then he'll pay nothing. For 6.5 hours, he'll pay $8.50. For 11 hours, he will pay $12, and for 9 1/4 hours, he will pay $12. So to get the amount he saved, we subtract the cost of getting the weekly ticket, which is $26, from the sum of $8.50 plus $12 plus $12. This gives us $6.50. Mrs. Verma has a restaurant. In the restaurant, each table has 8 chairs. Sometimes she puts tables together. The diagrams show how the tables are put together and the position of each chair X. The pattern of tables and chairs forms a sequence. Draw the diagram for 4 tables. All we need to do here is draw 4 columns of tables and place an X around the tables. Complete the table. From the sequence, we see that the number of chairs is increasing by 2. So to get the number of chairs for 4 tables, we add 2 to 12, which gives us 14. For 5 tables, the number of chairs would be 14 plus 2, which is 16. For 6 tables, the number of chairs would be 16 plus 2, which is 18. Find the formula for the number of chairs C in terms of the number of tables T. Since the number of chairs keep increasing by a constant value, we can use this to get the formula for the number of chairs. N in this formula represents the number of tables, which is T. AN represents the number of chairs, which is C. A1 is the first term, which is 8. And D is the common difference, which is 2. When we expand the brackets, 2 times T is 2T. 2 times -1 is -2. When we group like terms, 8 minus 2 is 6. So we have 2T plus 6. 18 tables are put together in this way. Work out the number of chairs needed. All we need to do is plug in T equals 18 into the formula we got in the previous question. This gives us 2 times 18 plus 6, which is equal to 42. Work out the number of tables put together in this way when 80 chairs are needed. In this case, we plug in C equals 80 into the formula. This gives us 80 equals 2T plus 6. When we subtract 6 from both sides, we get 2T equals 74. And when we divide both sides by 2, we get T equals 37. Mr. Patel is traveling by train to the city. He is going to the library. The travel graph shows his journey from Kila station to the library. Write down the total time it takes Mr. Patel to travel from Kila station to the library. From the graph, we see that Mr. Patel leaves Kila station at 9 o'clock and arrives at the library when it's 9:55. So the time duration is 9:55 minus 9 o'clock. This gives us 55 minutes. Work out the speed of the train between Lanai Station and City Station in kilometers per hour. We can use this formula to get the speed of the train. The train leaves Lanai Station at 9:25 and arrives at City Station when it's 9:35. This gives us a time duration of 10 minutes. To convert 10 minutes to hours, we divide 10 by 60. From the graph, the distance between Lanai Station and City Station is 30 minus 12 kilometers. When we type this into the calculator, we get 108 kilometers per hour. Use the following information to complete the travel graph for Mr. Patel. He spends 35 minutes at the library. Mr. Patel is currently at the library. Each box represents 5 minutes. So for 35 minutes, we count 7 boxes to the right. And since he's still at the library, we mark this as our next point. He walks back to City Station at the same constant speed he walked to the library. This means the rise and run of the graph from the City Station to the library, which is 4 units in the horizontal direction and 1 unit in the vertical direction, should be the same as from the library to the City Station. So we mark this as our next point. The train takes 20 minutes to travel from City Station to Lanai Station. For 20 minutes, we count 4 boxes to the right from City Station, and since we are now at Lanai Station, we mark this as our next point. The train stops for 10 minutes at Lanai Station. For 10 minutes at Lanai Station, we count 2 boxes to the right from Lanai Station. And since we are still at Lanai Station, we mark this as our next point. The train travels at a constant speed of 48 kilometers per hour from Lanai Station to Kila Station. First, we need to find the time duration for this journey. Based on this formula, we get T equals D over V. From the graph, the distance D between Lanai Station and Kila Station is 12 kilometers. And we've been given the speed of the journey to be 48 kilometers per hour. This gives us 0.25 hours. To convert this to minutes, we multiply 0.25 by 60, which is equal to 15 minutes. So for 15 minutes, we count 3 boxes to the right, and since we are now at Kila Station, we mark this as our next point. Now that we are done, we connect the points with straight lines. The scale drawing shows the positions of an airport and a train station on a map. The scale is 1 centimeter represents 2 kilometers. Work out the actual distance in kilometers of the train station from the airport. On the scale drawing, when we measure the distance between T and A, we get 9.6 centimeters. So using the scale conversion, which is 1 centimeter to 2 kilometers, we want to find the actual distance for 9.6 centimeters, which is what we are calling x. When we cross multiply and make x the subject, this is what we get, which is equal to 19.2 kilometers. Measure the bearing of the airport from the train station. This bearing is the angle from the north of the train station T to the airport A. Using a protractor, when we measure this angle, we get 45 degrees. There is a straight road that is equidistant from T and A. Using a straight edge and compasses only, construct the position of the road on the map. Show all your construction arcs. In other words, this straight road is the perpendicular bisector of TA. Using a pair of compasses, we stand at T, open the compass to a width that is more than half of TA, and construct a set of arcs above and below TA. Using the same compass width, we stand at point A and construct another set of arcs above and below TA. Using a ruler, we draw a straight line passing through the intersection point of the arcs. On the map, mark the two possible positions of Krishna's house. Label each of these points K. We are told Krishna's house is on a bearing of 203 degrees from the airport. So on the scale drawing, we measure an angle of 203 degrees in the clockwise direction from the north of A. We are also told Krishna's house is 8.8 kilometers from the train station. Using the scale conversion, 8.8 kilometers translates to 4.4 centimeters. So on the scale drawing, we first measure our compass width to be 4.4 centimeters. Then we stand at T and construct a circle. These two intersection points are the possible positions of Krishna's house. So we label these points K. The bus station is not shown on the map. The bearing of the bus station from the train station is 318 degrees. Work out the bearing of the train station from the bus station. In the illustration, we've marked the bearing of the bus station B from the train station T, which has been given as 318 degrees. We've also marked the bearing of T from B, which is what we are finding. Angles formed at a point add up to 360 degrees. So to get this angle, we subtract 318 degrees from 360 degrees. This gives us 42 degrees. These two are interior angles, which means they add up to 180 degrees. So to get the bearing of T from B, we subtract 42 degrees from 180 degrees, which is equal to 138 degrees. Line L is drawn on the grid. Find the equation of line L. Give your answer in the form y equals mx plus c. All we need to do is find the values of m and c and plug in these values into the equation. To get m, we first pick 2 points on line L. By applying the gradient formula, we have m equals 3 minus 0 divided by 0 minus 6, which is equal to negative 1 over 2. We can get c by picking the y-coordinate of the point on the y-axis through which line L passes, and that is 3. So we have y equals negative 1 over 2x plus 3. The points 9a and b3 lie on the line y equals 2 over 3x minus 7. Work out the value of a. A is the y-coordinate of the point whose x-coordinate is 9. So to get A, we plug in x equals 9 into the equation of the line. This gives us A equals 2 over 3 times 9 minus 7, which is equal to -1. Work out the value of B. B is the x-coordinate of the point whose y-coordinate is 3. So to get B, we plug in y equals 3 into the equation of the line. This gives us 3 equals 2 over 3b minus 7. When we add 7 to both sides, we get 2 over 3b equals 10. When we divide both sides by 2 over 3, we get b equals 15. Complete the table of values for y equals x times 3 minus x. When we plug in x equals -4 into the equation, we get y equals -28. For x equals -1, we get y equals -4. And for x equals 2, we get y equals 2. On the grid, draw the graph of y equals x times 3 minus x, for x is greater than and equal to -4 and less than and equal to 4. On the grid, we plot all the points in the table and connect the points with a smooth line. Write down the coordinates of the highest point of the graph for x is greater than and equal to -4 and less than and equal to 4. On the grid, we see that the highest point has coordinates 1.5, 2.2. The diagram shows a rectangle and two semicircles with diameters AC and BD. This diagram is a scale drawing of a running track. AC equals BD equals 60 meters. AB equals CD equals 120 meters. Complete the statement. 1 centimeter represents blank meters. Using a ruler, when we measure the length of CD, we get 8 centimeters. So if 8 centimeters maps to 120 meters, then what will 1 centimeter map to? This is what we are calling x. When we cross multiply and make x the subject, this is what we get, which is equal to 15 meters. Work out the total length of the running track in meters. The total length of the track is equal to the sum of AB and CD, which is 2 times 120 meters, plus the sum of the two semicircles, which is 2 pi times 60 meters divided by 2. When we type this into the calculator, we get 428 meters, rounded to 3 significant figures. Shriva walks at 1.4 meters per second. Work out how long it will take her to walk once around the track. Give your answer in minutes and seconds, correct to the nearest second. We can use this formula to get the time. The time is equal to the distance divided by the speed. We found the distance around the track to be 428 meters, and we've been given her speed to be 1.4 meters per second. When we type this into the calculator, we get 305 5/7 seconds. To convert this to minutes, we divide by 60. This gives us 5/2/21 minutes. To convert 2/21 minutes to seconds, we multiply 2/21 by 60. 2/21 times 60 gives us 6 seconds rounded to the nearest second. So the time it will take her is 5 minutes 6 seconds. Talan completes 1 lap of the track every 80 seconds. Work out how many laps he can complete in 1 hour. If he can complete 1 lap in 80 seconds, then how many laps can he complete in 1 hour, which is 3,600 seconds. This is what we are calling x. When we cross multiply and make x the subject, this is what we get, which is equal to 45. Naima completes 1 lap of the track every 88 seconds. Talan and Naima start running from point A on the track at the same time. They each complete a number of laps of the track. Work out the smallest number of laps they each complete before they are both at point A again at the same time. To get the time duration where they will both be at point A again, we need to find the LCM of 80 and 88. So we list the multiples of 80 and 88. From this list, we see that the LCM is 880. This means after 880 seconds, they will both be at point A again. For Naima, she would have completed 10 laps in 880 seconds. And for Talan, he would have completed 11 laps in 880 seconds. Using a straight edge and compasses only, construct the equilateral triangle ABC. The base AB has been drawn for you. When we measure the length of AB, we get 5 centimeters. Since the triangle is an equilateral triangle, all its sides need to have a length of 5 centimeters. So we measure the width of our compass to be 5 centimeters. Then we stand at point A and construct an arc. Using the same compass width, we stand at point B and construct another arc. When we are done, we draw two lines from AB to the intersection of the arcs to complete the triangle. Calculate the area of this trapezium. Here is the formula for the area of a trapezium. From the diagram, A is 16 meters, B is 24 meters, and H is 14 meters. When we type this into the calculator, we get 280 meters squared. Each interior angle of a regular polygon is 162 degrees. Calculate the number of sides of the polygon. Here is the formula for the interior angle of a regular polygon. We've been given the interior angle to be 162 degrees and we need to find n. When we multiply both sides by n, we get 162n equals 180 times n minus 2. When we expand the brackets, 180 times n is 180n. 180 times negative 2 is negative 360. When we group like terms, we have 18n equals 360. When we divide both sides by 18, we get n equals 20. The area of this triangle is 363 centimeters squared. Calculate the value of h. Here is the formula for the area of a triangle. We've been given the area to be 363 centimeters squared. The base is 6h and the height is h. Half of 6h times h is 3h squared. When we divide both sides by 3, we get h squared equals 121. And when we take the positive square root of both sides, we get h equals 11. This shape is drawn using two semicircles that have the same center. The large semicircle has radius 7 centimeters. The small semicircle has radius 3 centimeters. Calculate the area of the shape. The area of the shape is equal to the area of the big semicircle minus the area of the small semicircle. When we apply the area of a semicircle, which is pi r squared over 2 to both semicircles, this is what we have. When we type this into the calculator, we get 62.8 centimeters squared, rounded to 3 significant figures. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.